Good afternoon. This is Chemistry Module 8, and I'm going to kind of walk through one of these example problems, example 8.6. If I would suggest kind of writing things down as they're written here, not necessarily the sentences, but writing things down so that you can kind of follow along and make sure you understand what we're doing and why. Because the math is not difficult, but you have to know what math and what numbers and which measurements to use in order to solve the problems. So if we look here at example 8.6, it's actually in your book. The goal is to make 100.0 grams of GaCl3, and they give you this relationship here in step 2. And so we need 2 moles of Ga plus 6 moles of hydrochloric acid, or HCl, in order to make, or this arrow means yield, 2 moles of GaCl3 plus 3 moles of hydrogen. Remember, hydrogen is a homonuclear diatomic atom. So several things that you need to remember, some concepts that are important. These coefficients, this 2, this 6, this 2, and this 3 represent the number of moles required, at least in this case, required here to generate this many moles of product. So this is a recipe, this equation is a recipe that tells you how much of each you would need in order to figure of moles, remember not mass, that in order to find the number of moles of any other substance within the equation. So the first thing you'll notice, we're given the number of grams, and that does not help us with this equation. So the first thing that we have to do is to find out how many moles of GaCl3 are contained in this 100.0 gram sample of GaCl3. Remember, moles is just simply 6.02 times 10 to the 23 molecules. So how many molecules of GaCl3 are found in this 100 gram sample? And so so that we can use that number of moles and adjust our recipe using these numbers here, these coefficients. So this also means that we have to remember something very important as well. How do we figure out how many moles are in this 100 gram sample? Well, the key to this was in a previous chapter, right? If we find out the mass of one molecule of GaCl3 in AMU, okay, that will give us the mass of just one molecule of GaCl3. If we take that mass, that number, and we weigh out a sample in grams that is equal to that number, it will contain 1 mole of GaCl3. Let's kind of walk through that a little bit. Okay, then we're right here at step 3. This means the first thing that we must do is find the relationship between the mass of GaCl3 and the moles for GaCl3. Remember that the mass of GaCl3 in grams contains 1 mole of GaCl3. So we first have to find the mass of one molecule of GaCl3 in AMU. So we look at our use the periodic chart, right? So here is our molecular formula, compound formula for GaCl3. It contains 1 atom of Ga and 3 atoms of chlorine, or Cl. The mass from the periodic chart is 69.7 for 1 Ga atom, and that's in AMU, atomic mass units. 1 atom of chlorine is 35.5 AMU, but we have 3. So we do this little multiplication here. For 1 atom of Ga, it's 69.7 AMU. 3 times 35.5 is 106.5 AMU. Then we add those together and we find that the mass of one molecule, right here, one of these, is 176.2 AMU. Okay, but And that's helpful and good, but it only tells us, this number tells us that if we go and take a bottle off of the shelf that says GaCl3 and we then empty out that bottle and we measure out 176.2 grams of GaCl3, that 176.2 grams of GaCl3 will contain 1 mole of GaCl3. So we only find this AMU number because that number is the number of grams that contains 1 mole of GaCl3. And now we have a conversion factor, a relationship between the mass of GaCl3 and 1 mole of GaCl3. And we can go back up here now. So we have 100 grams. Okay, so we have a little bit less mass of GaCl3 than what contains 1 mole. So when we do this next step, you'll remember, or you'll realize that you're doing it right if we find that we have a little less than 1 mole of GaCl3 in that 100 gram sample. Because in order to have an entire mole of GaCl3, we'd have to weigh out 176.2 grams. We only have 100. So now we can convert that 100 grams of GaCl3 to the corresponding number of moles of GaCl3. And I'm just going to scroll down here to this next picture here. And so we set it up like a conversion equation. We start with what we know. We have 100.0 grams of GaCl3, and any number over 1 is simply still that number. And the parentheses just mean multiplication, right? And so how do we use this conversion factor? We know that our grams of GaCl3 have to be in the denominator because we want the grams of GaCl3 to cancel. And that will leave us then with moles. So for every 1 mole of GaCl3, there are 176.2 grams of GaCl3. And if you do this, it's multiplication, or essentially it's 100 divided by 176.2 grams of GaCl3, you will find that we have 0.56753 moles of GaCl3. But you have to remember, we have to go back and look here. There are 4 significant figures here, 4 here. So we count 1, 2, 3, 4. So this 5 is going to be the last number that we have for significant figures. But we have to look to the number at the right. If it is less than 5, that 5 will remain a 5, and we see that it does. If this 3 had been a 5, a 6, or a 7, or 8, or 9, then we would have risen this number, or rounded up, risen, that's silly, to 6, right? Little humor there. So, and this is true. Remember, so 176.2 grams of GaCl3 contains 1 mole of GaCl3. What this number right here tells us is that if I weigh out 100 grams of GaCl3 on a balance, it will contain 0.5675 moles of GaCl3, right? This number is smaller because I have less in my sample, right? 100 is less than 176.2 grams of GaCl3. Now we can go back to the recipe or to that chemical reaction, chemical equation, and find the ratio of moles of GaCl3 to the number of moles of Ga and eventually moles of HCl, because the question wanted to know how much of each of these. Right now I'm just going to focus on Ga. It's simpler, and since this is a sample, we're just going to stop right there in this first video. So let's go back up and here and look at this equation. I know now how much GaCl3 I have. We have 0.5, okay, I don't have that memorized, but we can go back down there and look. So we have less here, which means we're going to have, but our relationship is for every 2 moles generated, we need 2 moles of Ga. So here we go. To make 2 moles of GaCl3, we need 2 moles of Ga. But we only have 0.565 moles of GaCl3, so we're not going to need an entire 2 moles of Ga. So we use that relationship from that equation, this conversion factor, that 2 moles of Ga equals 2 moles of GaCl3. And we set that up again, right? So 0.5675 moles of GaCl3 Essentially, in this case, it's a little bit easier, right? Because we know that 2 over 2 equals 1, so we need the exact same amount of GA, same number of moles, 0.5675 moles. But then we're not done because it wants to know the recipe. We can't go to the balance and measure out moles. Now we have to convert these moles back to mass, which is measured in grams. Again, we have to remember the relationship. If we know the mass of one GA atom in AMU, if we measure out that amount in grams, that contains 1 mole of GA. So here we go. 1 GA equals 69.7 AMU. This was just simply, if you look at your periodic chart, this is that relationship. All of this does is tell us that if we weigh out 69.7 grams, that 69.7 grams of GA equals 1 mole of GA. So I can start with what I know. I only have 0.5675 moles of GA, right? That means, again, so for every mole, I have less moles, which means I'm going to have less mass. I'm going to use that conversion factor. Remember, the moles of GA have to be in the denominator because we want these to cancel. And so this becomes a straight multiplication problem. 0.5675 moles of GA times 69.7 grams of GA, where these moles cancel, and we're left with 39.6 grams of GA. And the reason there are only 3 significant figures here is because of this number right there. Okay, so this I'm going to stop right now. And what I would suggest is have you continue on, right? So now that we know those two values, you can start here again with our 0.5675 moles of GaCl3, and you can figure out how much HCl we need. So we would go back to our original equation, right? For every 2 moles of GaCl3 made, GaCl3 made, we need 6 moles of hydrochloric acid. So our ratio will be 2 moles of GaCl3 equals 6 moles of HCl. Once you know how many moles, again, this is going to be a smaller number, but once you know how many moles of hydrochloric acid or HCl we need, then you need to find the atomic mass unit of HCl, and then use that number. And that number measured out in grams equals 1 mole, and then you convert the moles of HCl to grams. And then you would have your answer. So why don't you try that, and maybe here in the next few days I will finish this problem and you can check, or actually I don't need to do that because this one happens to be in your book and you can check it on your own and see if you got the right answer. It takes a lot of time, but if you write down each step and understand what you're doing, you will be successful from this point forward. It just takes practice, it takes time, it takes a lot of paper, and your fingers will hurt, but hey, you will learn chemistry. Have a great day.